If we could get going again, that would be super awesome. Thank you. So I'm not going to say too much about Rhys Williams, except to say you were the first person in Google to take me to lunch when I first started this role, and so I thank you for that. And you're also a pretty active member of a lot of the IAB Council, so you're a face and a doer that I see around quite a lot. I know you've been 5 years at Google, and you're going to talk to us about a topic and a terminology and a technology we hear about more and more and more, and that's very much heading into the center of our lives. But you're going to give it a twist and talk about advertising and AI. So I'm going to hand you over to do your best. Rhys Williams from Google.
Thanks, Vijay. Appreciate it. So yes, my name's Rhys Williams. I lead the DoubleClick business across Australia and New Zealand. And I've been with Google and DoubleClick now for 5 years. And prior to that, I spent the entirety of my career in either technology companies or digital media companies. And I've been in the digital market industry pretty much since the very beginnings. I've seen it going through a lot of change. And, way back in the day, when we first started out, it was all about just trying to get ad serving and banners running on desktop-based sites, and then we sort of got all that going, and then the world moved very quickly into the mobile world. It was the year of mobile for many, many years, and now I think we have finally passed that point, and even Google talks about being a mobile-first company a lot of the time. And there's plenty more buzzwords around. We hear them all today. We're at a programmatic conference. We hear about the Internet of Things. We hear about a whole load of them. But today, I'm really excited to talk to you about something that we think is going to fundamentally reshape our world and reshape the way that we interact with technology, which is artificial intelligence, or even more accurately, maybe machine learning. And I guess in the spirit of today, and Vijay has pulled it out many times, in the spirit of simplification and inspiration, that's my goal here today, is to try and make what could be a very complex topic sound very simple, and hopefully demystify a few things, and hopefully you'll all learn something. And I know I heard Dylan call out before that people didn't want to hear about artificial intelligence and machine learning, but it's great to see so many of you here in the room. And I think I even saw, there he is over there. Okay, you might learn something as well, Dylan. So, so to help us, start off, I'm gonna start off with a video, which will kind of give us a bit of an intro into what machine learning and artificial intelligence is all about. So, if you can play the video, please, guys.
There have been a number of shifts in the way we think about computing over the past few decades.
The terminology artificial intelligence has come in and out of favor in the scientific community. Sometimes it's called machine learning.
We tend to call it machine intelligence these days.
I just call it intelligence.
And sometimes it's just the effort to build machines that are better.
So in the early days, everything was built on logic, doing mathematical integration problems, playing chess. But we realized that what the real challenges were the things that people can do every day.
The real world is actually very messy. Hard logical rules are not the way to solve really interesting real-world problems.
You have to have a system that'll learn to get the knowledge in. You can't just program it all in.
One of the subfields we call pattern recognition.
Artificial neural network,
Reinforcement learning, for example.
statistical inference, and probabilistic machine learning.
Supervised learning, unsupervised learning, and we're not quite sure what technique is going to lead to better systems. And in fact, it's probably not one technique for everything. It's probably a bunch of different techniques and combinations of those techniques.
It's a progressive thing. It's about building things that are slightly better, slightly better, slightly better.
Intelligence is really not going to be something that we ever succeed in defining in a succinct and singular way.
Predicting the long-term future is very difficult. Nobody can really do it. And the bad thing to do is take whatever's working best now and assume the future is going to be like that forever.
So you can see from that video, there's lots of different shades, I guess, of AI and machine learning, and it's still evolving very rapidly. And I think it's clear that that comment that was left there at the end, the perceptions of what's possible today will be radically changing in the near future. And so that brings us to our consumers, and our consumers' expectations are changing rapidly as well. If you look at the screen on the left there, when Google launched back in 1998 and created this thing called Google.com, first index of the web, it was considered at the time something pretty amazing. You could finally get all those web pages in one place. It was almost some kind of form of artificial intelligence back then. And fast forward to 2007 when the iPhone launched, it too was a pretty momentous occasion. You had this massive amount of computing power in this little device that you could hold. There was an app store, and you could have access to the internet right there and then. What an amazing device. And if we fast forward to today, we're all now ordering food on Uber Eats to deliver it home. You can book a hotel in a matter of seconds. You can talk to somebody through video conference on the other side of the world. You can find a date by swiping your finger, or maybe even more recently now we're starting to talk more to our devices and our phones, and this has now just become kind of normal behaviour for all of us. Whereas a couple of years ago this seemed like pretty amazing stuff, and so expectations are changing. So let's go into a couple of definitions. What is it? So let's start at the top, optimization. I think you all probably have a good idea of what optimization is. We've been hearing a lot about it today in the marketing sense, but it's essentially making the most effective use of a situation. Then we have automation, which is using some kind of technology to make things run a lot easier and a lot faster. And then artificial intelligence. So the definition, the best definition that we can come up with is it's the science of making things smart. So it's a pretty generic definition, I agree. But what does it really mean? It means about improving tools and improving products to make all of our lives better through smart intelligence. And then within that, there's a subset of artificial intelligence called machine learning. That's what we're going to talk a bit more about today. And that's where we're teaching computers to learn from data rather than having a set of pre-programmed rules. And as you heard from the video, there's very many different types of machine learning that are still kind of evolving. And so why am I talking about this now? Why has this suddenly come up, and why is it getting a lot more airtime? I mean, artificial intelligence in itself is not particularly new. It's been around since the advent of computer science, and there've been those sorts of models all the way back to the 50s, but it didn't really get any traction until now. Even kind of 5 years ago, it still didn't really have much traction. So there's two fundamental things that have changed, which is why it's starting to happen now. The first one is the abundance or the availability of computing power, en masse, has increased exponentially. And the second one is the number of data points and data touch points that we have access to through all of our interactions every day has also increased dramatically. And so for machine learning to work, you need both, because there's no point running a model and then having it spit out an answer kind of 2 weeks later. That's just not going to work. You need it to run now. So you need fast computing, and you need lots and lots of data to be able to learn from in that in that short amount of time. And the other fundamental shift, it's a change in the way that the computing is done with these vast amounts of data, from simple kind of rules-based programming, where you might write, if this, then do that, to a model where the machine learns from a lot of data. So let me give you an example. So who recognizes the gentleman on the left there? Anyone want to call it out? Garry Kasparov, absolutely. The Russian Grand Russian chess master. And the picture on the right? Not Watson, Deep Blue. Whoever said Deep Blue? Yes, IBM's Deep Blue computer. And back in the 90s, during the late 90s, it was a pretty momentous event when the IBM computer beat Garry Kasparov at chess. It was the first time a computer had ever done that, and it was pretty momentous day for computing overall. But this is actually a very good example of a rules-based programming at work, because the IBM Big Blue computer, as great as it was, could only do one thing, and that was play chess. Couldn't play any other game. No other, even games that were far simpler, it couldn't play it. It was programmed to do one thing and do it very, very well. And that's the fundamental difference between what happened then and what's happening now with machine learning. Machine learning is about building software that's not pre-programmed with rules, but rather that learns from data. Let me show you another example. In a sec, we'll play this video.
Run this video now. This is a 1-minute video. This is Space Invaders, the most iconic game probably on Atari. And this first minute, this is before the first time the AI has ever seen this data stream. So don't forget, it doesn't know what it's playing, it doesn't know what it's controlling, and you can see it's actually losing its 3 lives. It's controlling the rocket here at the bottom of the screen, and it's losing its 3 lives immediately because it doesn't know what it's doing. But after you leave it playing overnight on a single GPU machine, you come back the next day, and now it's superhuman at the game. It's learned for itself through experience how to play. So you can see now every single shot it fires hits something. It can't be killed anymore. It's worked out that the pink mothership that comes across the top of the screen in a second is worth the most number of points. And it does these amazingly accurate shots to do that. And you can, if those of you remember Space Invaders, as there's less of them on the screen, they go faster. And just watch the last shot that it does, the rocket does. There's this predictive shot to hit the last Space Invader. So you can see how perfectly it sort of modeled the game world and that data stream. So accurately, it can predict ahead of time what is going to happen, just from the pixels on the screen.
So that was Demis Haspizis, who's the CEO and founder of DeepMind, a company that Google acquired in 2014. And he looks like he's a pretty unassuming guy. Apparently he's a massive Arsenal fan, and he's a typical kind of North Londoner. But I guarantee you, he's always the smartest person in the room wherever he goes. And so, I mean, that was great. They played Atari games. Then the DeepMind team set themselves the challenge of playing a much harder game, which is a game called Go, which has originated in China and is widely kind of recognized as the most complex game that mankind has ever created. And so they set themselves the challenge of beating a human player. And the way they did it was they uploaded hundreds of thousands of amateur games into the platform. And they built models, and then they trained it, and they refined it. And it took them a year to train this computer. And then they thought they were ready, and so they went head-to-head with the world champion of Go, a guy called Lee Sedol, Korean guy. And we're happy to say the computer won 4 times out of 5 in March 2016. So this is a pretty big turning point for a lot of the world. And you can see by some of the quotes that are up there on the screen, some pretty important people thought this will never happen in my lifetime, and I thought this would be 10 years away. But so, it's really starting to happen. So, okay, so machine learning is great for winning games, all right, but how does that kind of help all of us? Well, for any of you who are a CFO in the room, or perhaps have to answer to a CFO and, justify your budgets, you might kind of like this one. So, Google's data centers, as you can imagine, Google consumes a lot of energy in our data centers around the world. In fact, in 2014, I think it was estimated that in the US alone, we draw enough kind of energy and power to the equivalent of 6 million US homes. So energy optimization has been always a big part of what Google has been about. We build our own servers, we do a lot of investment in green energy sources, and over the years the teams have done a lot of good work and invented a whole bunch of stuff to optimize our energy resource and our energy usage. But breakthroughs were sort of few and far between until they brought some of the DeepMind team in and started using some of these machine learning algorithms. And once they applied that and trained the systems on resource usage, they managed to reduce our cooling costs by 40%. So 40% is a massive number on a super highly optimized system already. And in fact, it increased the overall energy efficiency of our data centers by 15%. So that's a phenomenal result. And this was, again, another big turning point, even within Google, that some of these technologies can have a really profound and big business impact. So let's just go a little bit deeper for a second and go to another subset of machine learning called deep learning. I'm not going to go too techie here, I hope. But deep learning is it's a field, I guess, that uses neural networks. And neural networks are basically trying to imitate how a brain works. Okay, think of it that way. So have a look at this example and take image recognition. Have a look at the picture on the left. And you can probably work out what it is because we're all humans. If you can't tell, that's a dog in the basket. But so, how would a machine recognize what's in the basket? So the old way of doing it would be you'd write a program with a set of rules that would look for 4 legs, some fur, a tail, 2 eyes, a wet nose, and some ears and so on. That would be the old way of doing it. The new way with machine learning would be to upload 100,000 pictures of a dog and label it, this is a dog, and 100,000 pictures of something else and label it as not a dog, and then let the machine work it out. They're all different pictures, of course. And the neural network works by trying to make predictions based on its ability to discover patterns in that data. And obviously, the more data that there is, the more patterns it can discover. And the more layered that data is, the more patterns within patterns within patterns that it can find. And so, basically, after a period of time, what happens is that kind of output layer that we're looking at up the top there is watching all the errors, all the signals, and it comes up with a prediction. That's essentially what it comes out with. And it says, for example, okay, I think that there's a 95.67% chance that this is a dog. So, okay, we'll call it a dog. That's essentially what it does. It tries to predict as accurately as it can. But it does take time to learn these things with computers still, even with all the compute power that we have. And just to give you some perspective, compared to the human brain, if I asked my 5-year-old son that, if I said, that's a chair over there, and then kind of a couple of minutes later I came back and said, what's that? I hope he says it's a chair. But he should say that's a chair. But it would take a computer a lot longer for us to teach the computer that that's a chair because of, so we still got a long way to go, I guess, in comparison to where the human brain is at. Got a few more examples. So we all know that picture on the right, is a stop sign that's covered by snow because, we've all seen stop signs many, many times. But, how does a computer know that? If it's the first time they've seen that picture, then that's a real problem. And this is starting to surface a lot in Google's self-driving car project. The reason it's taking us a long time to train these cars is because there are so many different permutations of what the computer needs to react to and see, and it needs to learn from. So there's a lot of effort going on on the self-driving car project to make sure that we are teaching it, because it's not an excuse to say, well, I couldn't recognize that was a stop sign, so I just drove straight through it. So that's obviously not acceptable. Another example that's kind of close to home, I guess, for us here in Australia is around skin cancer and skin recognition. So this is another image recognition example, but the University of Stanford was one that used some techniques in this example. Put many different images of skin spots into the network and sorted those images, gave them labels, and started to teach it what was a malignant skin spot, what was cancerous, what was benign, and so on. And then after all the training and the labeling and sorting it, the computer was able to come out with 90% accuracy on what type of skin spot it was, and that's equivalent apparently to a well-trained doctor. So that's pretty impressive. Now, does that mean that all doctors are out of business now and don't have a job? Of course not. It doesn't mean that. It just means that their jobs are going to become more accurate, more faster, and ideally saves them more time to do more consultation. Google Translate is a great example of machine learning. So for those of you that remember the first iterations of Google Translate, it was actually a lot of fun. You could type in a sentence in another language and see what it would come back in English, and it was sometimes kind of well out of whack. And that's because it was based around rules-based programming. Language structures are very different between different languages, not always the same. And now it's come such a long way that it uses image recognition and in fractions of a second is able to translate images on the fly. Now, if this is where you need big, fast compute power. If this took 2 minutes, it wouldn't be useful to you. But the fact that it takes a second is now useful, and that's why we're all starting to use it. Speech recognition depends a lot on machine learning, and I think it's really interesting with speech recognition because you've really got to get it right here, because as opposed to running a search where you get a whole list of results, with speech recognition you really only get one chance to get that answer right. It's got to respond with the right answer. So there's a lot of work going on at Google, but also with Apple and Siri and Amazon and Alexa are all basing their voice recognition programs around artificial intelligence. I think these will get a lot better. So there's a bunch of examples there, but I think this has given, particularly some of those other ones at Google, given the leadership at Google a lot of confidence that this is definitely the way forward. In fact, Sundar, our CEO, has come out very publicly and said we are as Google, are moving from a mobile-first company to artificial intelligence, or more accurately, a machine learning-led company. And you'll start to see it surface in the vast majority of products that we run. In fact, all our consumer products, there's a bunch of them today that are using, using machine learning that you probably don't even know about. So, search uses it a lot in the search ranking and speech recognition. Gmail, for its spam classification, uses machine learning to weed out 99.9% of all spam. Google Maps, for those of you that use it, is able to learn from traffic patterns and traffic and what's happening in real time and recommend a new route for you while you're on the go. And there's many, many more. But we're here at a programmatic conference and an ads conference, so I will bring it into ads. And I'll give you a couple of examples, I guess, of how we're starting to see this surface in advertising. So let's say, typical problem, you want to promote, your app. And, there probably was once a time when, having access to demographic information, or at least segment information, was great, and it's probably the holy grail if you can get very accurate information, put people into those segments. But like the quote from Todd from Netflix says there, that demographic information is almost useless, because here's a shocker for you, there's actually 19-year-old guys who watch Dance Mums, and there's 73-year-old women who are watching Breaking Bad and Avengers. So true, right? We as in the marketing world, we're all very guilty of creating segments and putting audiences in buckets and really kind of, defining those models. But it's not really the same way as people interact with the world. And if you're using those kind of, rules-based technologies, then you're missing out on a lot of opportunities. So one of the products that's available in some of the Google ad platforms is a program called Universal App Campaigns. Helps you drive app installs for your campaigns. And it focuses on finding the highest value users that you can get. And it does this by looking at people who already have your app installed and starting to build a profile. What other apps do they have installed? How often do they use it? What do they do inside the app? What devices are they on? What time of day do they watch it? And so on and so on and so on. Builds out as deep a profile as it can, and then takes that and tries to find very similar users to that out in the market. So think about it. I mean, it is, it's a version of sort of lookalike audiences or similar audiences that you probably hear about all the time, but this is much richer and deeper, and is using a lot more signals than just, a basic cookie match. In the search and programmatic world, if we think where this all started, in the beginning, if you had a few keywords to do search, or you had a bit of targeting and run your bidding, happy days. You can program your tools and away you go. Start to get a bit more complex when you start to overlay things like time of day and device, location, interests. But you can still kind of manage this stuff somewhat manually, with a good set of people that know what they're doing. But nowadays, with the options that are available to all of us when it comes to targeting and finding, and is both relevant for search campaigns and for programmatic campaigns. You can build your attribution models and plug them in, put your first-party data in, third-party data that we heard before. In essence, it's starting to become unlimited. There are, in fact, going to be millions and millions of data points that can inform whether you should be bidding on that impression and how much you should bid on it to find that right person, right time, and right message. And so to solve for that, you need tools. And certainly at DoubleClick, it's the direction that our product set is heading in, is building automated and smart bidding techniques that are based around machine learning. I won't go through that one. The last one is around attribution, the last example. We could do a whole other talk on attribution because it hasn't been talked about much yet, but we could. And so we're starting to apply machine learning models to some of our data-driven attribution. And at the most simplistic level, I guess, at attribution, what are we trying to do? We're trying to help understand the allocation of credit to advertising touchpoints. So the model here, we look at two converting paths that are very similar, and then calculate the difference of removing one of those touch points, and then you can work out the impact of that touch point when you compare the two paths. So that's a very simple model. But of course, every campaign doesn't just have two paths. It has thousands and thousands of paths, usually, across multiple different devices and over longer periods of time. So lots of data, lots and lots of data generated. So how do you kind of put that into a data-driven model? Again, you can do it through rules-based, I guess. Very difficult, takes a lot of time. It's often why attribution reports take weeks or even months to kind of get out. In these platforms now, we're able to calculate and produce some of this information within seconds within the platform. Now, it's not the, it's not the only sort of silver bullet, but it's a big step forward into helping you to analyze that data and make the most out of it. So, if any of these are the sort of, there's just some examples of how we're using it today. And this is only going to grow in the future, not just with Google, but with other platforms as well. But, if you're looking for unique audiences, or you're struggling with the amount of data that you have, or, needing deeper analysis, then machine learning and machine learning techniques could help you to get to those answers. And indeed, so I've talked a lot about the things that we're doing on our platform. But one thing that Google has done a fantastic job of in this world has made the core of these technologies available as an open source platform. And the platform's called TensorFlow. As you can see, it's in the middle there. And it's available for free for usage alongside the Google Cloud platform, which allows you to get access to large amounts of computing power. And I guess the idea is here, bringing your own data, CRM systems, point of sale data, and so on, coupled with the machine learning algorithms as part of TensorFlow, and maybe some of the data that gets pulled in other Google platforms, this will be able to help you. And so we're going to continue to develop down this path and add new features to make it smarter and better and more powerful as time goes on. So I'm getting the red light flashing at me. So on my last slide, so for just sort of a couple of things to remember in closing, I guess, is that we have reached this tipping point now with computing power. So the machines can learn from vast amounts of data, and machines learn much better, with sets of data rather than doing pre-programmed rules. The second one is that consumer expectations will continue to change and increase. What is seen as innovative and amazing today, in a couple of years' time, will just become table stakes and something that we can't believe we ever lived without. That's also very true in the way that all of us as marketers interact with users. And lastly, around your data strategy, I guess, in the same way that sort of going mobile, didn't mean just sticking a desktop site on a mobile. It means, using data means that you need to have something customized. You need to have a dedicated strategy around it, and the right technical infrastructure. And I think it's important for us to all remember that no matter what industry you're in, whether you're, playing games with Space Invaders or curing cancer or whatever you're doing, or trying to find the right person, at the right time with the right message, we're all in the business of data, and understanding it and making the most of it is what's going to differentiate you from your competition. So with that, I'll finish. Thank you.
Crazy box speaker, so we've got probably time for one or two questions. Let me just very quickly kick it off, Rhys. Thank you for that. How much of this is sort of back end, sort of stuff that's away from us that are transacting at the front end because it's kind of deep in your Google technology, and how much of this is stuff that we need to be kind of thinking about and giving consideration to? How would you advise us to be thinking about AI?
Yeah. So, I mean, a lot of the examples I showed there in the ad products is stuff that's all in the back end. And the way that people go about training, I guess, these systems is, happens a lot of it behind the scenes. The way it surfaces in our ad products, I guess, is being very clear on what your goals are and what your outputs are, and I guess, having a little bit of belief and well, I mean, you've got to test and iterate, of course, but knowing that the machine is going to be able to kind of deliver on it and find that right person at the right time.
Cool. Okay, thank you. Probably got time for a question if there is one. It's one of those. Oh, there is one. There you go. I'm going to attempt to toss this.
Oh.
Thanks for the pass. A very quick question. Do Google believe in singularity?
Does Google believe in singularity? What do you mean? In what context?
Singularity point. So essentially, the day machine will surpass the human being and be smarter than the human being. Like, for instance, Elon Musk believes in. Will you have like a machine, a CEO machine one day?
So I think we've got a long way to go before we get anywhere close to that. As I said, I think we're right at the beginning of what computers can do and where this can end up. It's probably not a question for me to answer. I'm not in charge of product strategy. I wish it's maybe a bit beyond my, but no. I don't think, certainly in the way that, you know, all the examples that we're sort of talking about today, machine learning and artificial intelligence is there to enhance the human experience, not replace it or not take it over.
Brilliant. I think we are up for time. Rhys, thank you so much.
No
Great
worries.
presentation. So one more session before we go into the coffee break. In this room, how to combine data and creative, and in the other room, how we aim for truth in measurement, from William Paling at IAG. So if you take a minute to find your room, we'll get started.